Computerized Start is brought to you by my awesome patrons on Patreon, and by your tips and memberships on Ko-fi. These and other channel supporters make my live streams possible. You too can become a channel supporter with tiers starting at just $1. And as always, thank you for all your support, including sharing, chatting, liking, and subscribing. Now roll that famous logo animation! Good evening and welcome back to the channel. I am Justin D. Morgan, your host of Computerized Start, where I explore the computers of my generation to inspire the next. And I have to say, I left myself a huge old mess on my workbench last time I streamed. Yes, look at this Franklin. It's a mess. I need to put it back together tonight. Yeah, let's see. We have Joe, Trina, Retro Tech or Die, Mike from Mike's Mac Shack, all in the chat right now. Welcome. Yes. So this is the Franklin Ace 1000 Plus. I think the Plus just means it has the color circuit built into it or something like that. I don't know. It's kind of hard to tell what the Plus means. I guess at least it's the Plus model and not the minus model, because the minus model would probably imply there was something missing, whereas Plus implies there is something extra. So, tonight, I have a few seemingly random things to do to the Franklin Ace 1000, but they are all necessary to put it back together, because I am going to wrap up working on this for now. I know it's not done, but I need the workbench for other things. And also, I also have seemingly more parts floating around for this than I know what to do with. Ah, that's right. But first, there was a reason why I was clearing the workbench. Oh, yeah, I just about did a thing that no famous YouTuber has ever done, and put my address smack dab in the middle of the frame. Anyways, I received a package last week. Well, actually, I received two. But I hope Tom Barber will forgive me for not spoiling what's in here tonight, because it's for another video, an actual scripted video. So I'm not going to spoil what's in here, and Joe is sworn to secrecy, because he probably has a good suspicion of what's in there. So yeah, I had to beat you to that, Joe. Now this one, though, is kind of a mystery, because I knew Tom was sending me that item, and I do appreciate it, Tom. It is going to be a great item for the scripted video that it's going in. But I think I know what this is, but I don't know who sent it to me. And actually, I could kind of use it, could probably use it tonight. So I am going to... Oh! What do you know? So I didn't know who it was from, but this is apparently from Retro Tech or Die. I put on my Twitter last week my Amazon wish list and pointed out there were some things that I would like that were on Prime Day sale. And after the incident last time where I shorted things out to the stainless steel workbench, plus these are incredibly handy for soldering on, it was a 2-pack of these silicon mats for like $8, so like $4 a piece. They're not as large as the ones I normally use, but, well, for smaller items, or just quite honestly, for me not doing completely stupid things, like now, looky there, I can set the Franklin keyboard and all of its exposed pins. I now can set it on something that is insulative and not short 5 volts to the power supply. Yes, thank you, Retro Tech or Die. These will come in quite handy, quite possibly as soon as tonight. Actually, I will have to, I think I'm going to have to use the slightly bigger one for the power supply, but I will be able to make use of those while testing things before I put things together. The board is just a... Oh, you got some for you too, yes. So I will definitely put those to good use, as well as the item from Tom Barber. Good use. So, all right. So on tonight's repair agenda, we have a couple things for the Franklin Ace 1000. Let me see here. Let's see. So, I'm going to replace the 2 safety caps in the power supply because for now I'm not going to do anything else to it. Yeah, I'm not going to recap it yet. I may still recap it. I'm still torn between just replace all the capacitors or replace the entire thing with a shiny new reactive micro power supply board. So, in the interest of putting things back together, I'm just going to go ahead and replace the safety caps because, well, I removed them, so I'm going to replace them. So, and speaking of power supplies, Joe's Computer Museum has Apple III power supply recap kits available. So for those of you that have an Apple III, go to Joe's Computer Museum. He's got cap kits for your power supply. Now if I could just convince someone to make a Franklin Ace recap kit. Well, actually, I think I've got in a Mauser saved project. I have all the caps in a saved project for this. It's just a matter of ordering them. So I haven't decided if I'm going to replace it or recap it. Everything seems to be good. It's the high voltage transformer is kind of the item that they have a lifetime of 20 years, and I don't know how many years this transformer was used. So I suspect I'll go the cheapest route for this since it's working. But, all right, so previously I removed the 2 RIFA caps. The original RIFA caps were a 0.22 microfarad X class and a 0.1 microfarad X class. And I should have these are the closest I could find in replacements. They are X2 class. Yes, they are RIFA brand, but they were available and they fit the pin spacing. So I went with them. All right, now the only thing is I don't remember which goes where, but luckily I took a photo of it. Now it's just a matter of finding the photo. Yes, okay. So the 0.22 microfarad goes here. Oh, first, it would help to remove the screws that are holding the power supply down, which I did so that I did not short things. And then we will Yes, I did take a picture, Trina. I think someone reminded me to do it during the stream where I removed those capacitors because that is something I otherwise would have forgotten to do. But I have a picture, and C2 is the 0.22 microfarad, which is also 220 nanofarads. And that RIFA cap is... All right, I think the pin spacing is... Nope. Pin spacing is good. And this one goes here. And yep. And I'll solder these in, and then you'll never know. Well, actually, I suspect it will be obvious they've been replaced because they won't be all cracked and 10 seconds away from being explodey RIFA caps. So while I wait for the soldering iron to heat up, the other things I have tonight are I have some W65CO2 S6 TPG-14 chips. Brand new from Mouser. So I'm going to modify one of these to work in the Franklin Ace so that I can put the 6502 back in the Atari. I have 40-pin sockets in case I need them. Hopefully I don't. Yeah, yes, Joe. Steve has to be present for all RIFA cap explosions. But not only does Steve have to be present, he has to be completely unexpecting it. Or at least that seems to be the rule if Steve is at Mike's house, or Mike's apartment. Steve sits down beside an unsuspecting Mac that Mike plugs in. Mike then just goes way far away from the computer. The RIFA cap goes pop, psss, starts filling the room with smoke. Mike's off laughing somewhere, ha ha ha, sucker. And Steve jumps and goes, whoa, or something like that. How'd I do, Mike? Does that sound about right? All right, so I'm going to solder these caps in. And then I'll put the power supply back together. Well, actually, let's see. Let me get this one here. I know it's kind of hard to see what I'm doing, but I've tried to get the wire harness out. This wire harness here, I've tried to get it out of the socket, but it's just kind of stubborn. I can't get it out. So I'm just using leaded solder to put these in. All right, I think they're in. Yeah. All right, I'll clip the leads. All right. Safety caps are back in. Now, granted, they are more for, I think, electromagnetic interference. But they are, I think they are called safety caps because they are designed to, if they do fail, they are designed to fail in a specific way, especially if they are the kind that go between line and ground. They are designed to fail open. because otherwise that would be really bad. Yeah, power smoothing kind of to, I guess, to keep the high frequency noise from being backfed on the line. So, but they are designed to fail, at least the ones that go between, I guess, line and ground. Although I think the other ones might be designed to fail open as well, just because, I guess, neutral to ground, well, wouldn't be as bad, but it would be bad. All right, let me see if I can't find the bag of screws that goes to the power supply of the Franklin. See, that's the keyboard, so I do need to finish putting the keyboard back together. Let's see here. Let's see, that's one of the power supply bags. See, the good thing is I actually put these screws, let's see, I think those are the case screws. And up, here we go. Of course, the one that was actually, there we go. Hey, Adam. Well, welcome. I just replaced the 2 safety caps, and that's all I'm doing to this power supply right now. I'm gonna go ahead and put this thing back together because I have another project to work on later in the week. So I kind of wanted to get my workbench back in some resemblance of order. So for now, this is as far as I'm going to take this power supply. Just replace the safety caps, that's it. The fan is, well, I mean, the fan is a line-powered fan, so it's noisy. This grate, I'm sure, is not great in terms of helping it be less noisy. But at the moment, that's all I'm going to do with this power supply. At some point, I'll come back, I'll recap it, or replace the board with a I'm kind of leaning towards recapping it, because I think the caps are not that bad for this, even though there's like 4, 8, 12, 13. I think there's like 13 caps. 15 if you count the safety caps, but I just replaced them, so. But for now, I guess if I do recap it, or even if I replace it with a reactive micro board, I probably will look into replacing the fan. I know some people say, well, that's the ambience of the machine, but, well, maybe some things I will, yeah. Yeah, the RIFA caps will smell nice later, but since those are brand new RIFA caps, they were the best fit for this power supply, because last time I tried going the non-RIFA route, I really didn't like the way the replacements fit, so I decided I would just this time around go for the RIFA ones. All right, I think I've got some more screws somewhere. Interesting. I have... Yeah. All right, I think I got another bag of screws somewhere that I've misplaced. or I put the power supply and the case screws in the same bag. Let me see here. That's 4. Yeah, all right. I think I did do something silly. Yeah, I think I did something silly when I put the screws in bags for this thing. Because, let me see here. All right, I think I may have to put some other things together, and then I will eventually figure out which ones go in the power supply, because I did something really silly. Or there's another bag that I have dropped on the floor and haven't found yet. So, all right. Okay, well, the power supply is recapped. I will move on, and then hopefully we'll find the mysterious, elusive package of screws, which is probably fallen somewhere. You know, is it fixed? No, Retro Techie, it's not fixed yet. But I am glad you still found some vintage retro things at the flea market. All right. I guess the next thing, because I would like to put it back together before I completely drop the screws. So, because they're right beside me in a very dangerous spot. Anyways, I think last stream I tried to find this floppy disk upstairs. And it was hiding from me. It was not where I expected it. So we'll come back to this, but this is a PFS write disk. Unfortunately, I can't run this word processor on this computer. Fortunately for you all, I can't run this word processor on this computer. Because do you really want to see me process words? I don't think so. The labels come off of it, but we'll come back to this momentarily. It supposedly has a dictionary on the back, I guess. I don't know how current the dictionary is. It probably doesn't have all the cool retro terms. That is the TexElec invoice that doesn't apply to what I'm about to do. So, this is the thing that goes on the top of the Ace 1000 Plus, which I have removed the screws from because I ordered a new floppy drive belt for this floppy drive, even though I'm not sure it needs it. But this is a Console 5 fabric reinforced rubber belt for Shugart floppy drives. And I ordered it without taking this thing apart. Hi, Jeremy, welcome. Because I thought the drive looked familiar. And lo and behold, well, first of all, the parts are actually on this thing, and right here's the screw kit that was just hanging out. Oh, that's cool. It even has the number, the 1 and 2 numbers that you put on the drives that haven't been applied yet. Ooh, score. But the hardware for the second floppy drive was just hiding down in here. There's the RF shield for the second floppy drive. So I just need to find a Shugart drive. But sure enough, I thought I recognized it. So I just ordered before disassembling, and then I guess the other day I was curious how well I did. But yeah, you ordered a floppy drive belt, aka a black elastic band. Yeah, that's about the truth. So anyways, I figured I would well, oh, actually that's a reinforced band right there. So actually, I don't know if I should replace that, because that actually, when I first looked at it, I thought, well, it's rubber, but maybe I'll go and replace it. But this is actually it's in really good shape. Yeah, these belts usually last forever. Well, yeah, I'm just going to put the original belt back on it now that I've checked it, and probably caused myself lots of headache and frustration of... Actually, probably not. Oh, look, I think I already got it back on. Yay. Okay. They're fabric belts. Okay, that's good to know. Throw in an elastic band. Okay. There you go, Retro Techie. I threw in an elastic band. Yes, yes, yes. Thank you. I'll be here all night. Rubber band or bust. Joe. I probably do have a rubber band down here somewhere. All right. So I guess what I will do is I'll go ahead and put this thing back together. Yeah, this was really cool. So anyways, so this is, well, it's in its metal box for probably RF reasons. And yeah, so it's got a couple axial caps on the board. So I guess at some point when I recap everything, I'll probably come back and get those. Especially because it looks like they're 85C, but they look like they're in good shape. But yeah, this is actual, there we go. If anyone's wondering, Shugart Associates Model 390R, serial number MD5234, made in USA. Belt's in good shape, and well, you'll get to see the boot status sooner rather than later. So I do know the I did find the service documentation, and Franklin does recommend getting the same model floppy for drive 2. So I'm not sure how important that is, but the service documentation seems... Oh, it does help to not have the hardware right under where you're trying to set the metal plate. Uh-oh. Oh, that was just one of my sockets. Okay, have not knocked screws off onto the floor yet. So the instructions in the service manual say to make sure that drive 1 and drive 2 are the same type, because there actually was apparently a second manufacturer of drives. It was MPI, I believe, that also made drives for Franklin. So I will see if I can't find a matching Shugart mechanism, because I would like to put the second floppy drive in this, because it would be so cool. And yes, the Shugart drives are awesome. They sound awesome. Actually, it does look like this does use the Apple 20-pin interface, Adam. But because Franklin literally copied Apple. So, oh, and Jeremy, you probably are, yeah, actually, I already told you, I did get your box today, so I haven't had a chance to open it yet, but. All right. Yeah, I think for this, it needs to be the Apple 20-pin interface. But I bet if I took a, yeah, only the controller card makes it Apple compatible. Okay. Well, then maybe I could, if you just want to dig up a generic one, I can probably try to install it. I was actually somewhat tempted to just order an. Yeah, maybe I might do that, Jeremy. Since it's a repair package and not a other type of package, I wasn't going to do a dedicated unboxing video for it. But yeah, if we've got time, we'll take a look at it at the end of the stream as a teaser for the next repair. So anyways, if anyone's wondering, this basically apparently replaces the top of the, so instead of the top that looks like the Apple style top, it goes on top of the Franklin and probably makes it harder to put a monitor on top of it. And basically it holds your 2 floppy drives. So at least I put that back together, and should I manage to break the band for the floppy drive, I have a spare band, which I will put somewhere where I remember it is Apple. Hi, Geek with Social Skills. Yes, thank you for the V20 processor. I will actually hopefully finally be able to send a set of suspect processors to someone on Twitter who, I don't know how I managed to find them, but basically they're one of the people that I think removes dyes from chips for investigation. I don't remember who it is right offhand. I'd have to look it up. But anyways, he was wanting people to send him fake chips. If you'll remember from the Emerson 8000 EC, I tried to put a number of V20 processors in it, none of which worked. So I reached out to him on Twitter and said, hey, I have these V20 processors. I don't know if they're fake or not, but I certainly couldn't get them to work. Would you like to take a crack at them? He said, sure, but it would be really helpful if you could send me a known legitimate V20 for comparison. I said, all right, well, let me see what I can do. And Geek with Social Skills is going to be kind enough to send me a real V20 so that once and for all, hopefully I will be able to solve the mystery of those V20 processors. Are they real? Are they fake? So that will be cool. Hi, Tom Barber. I hope you'll forgive me. I unboxed my other Prime Day gift, but I'm saving yours for the video that the item is for. So I do thank you for sending this my way, but I don't want to spoil the fun. So I have left it unboxed, although Amazon didn't send it in a box. So I guess I've left it unbagged, or whatever they call that package. But yes, thank you, Tom, for sending that fun item my way. And I hope it will make my next scripted video a little more fun. And hopefully I'll get it out soon, because actually I ordered one last thing for that video, or well, actually two last things for that video, and I think Amazon shipped them today, so hopefully I'll have those Wednesday and might be able to film the bit piece that goes in the video. So, all right. All right, see here, next item. So we got the floppy drives back together. I got the power supply sort of back together until I figure out where the screws are. Oh, I guess now's as good as time as any to take a look at the motherboard. All right. So, this is, well, right there's the 6502 processor. And that is actually the processor from my Atari 400. Because the processor that was in this Franklin Ace was dead. But I want to put this back in the Atari. Well, partially because this is a 6502B. So it is, well, it was in the Atari. So I can't just replace the one in the Atari with a regular 6502, because I think the B runs at 2 megahertz, I believe. So I would like to put this back in the Atari. Maybe at some point I might try the replacement CPU in the Atari, but I have another plan here. Now I'm going to go ahead and put this back in the Atari 400 CPU board, which I have inconveniently, well, it's right here. Interestingly enough, they are both Centertech 6502s, although this one's just a 6502 that was in the Franklin Ace, because it just runs at 1 megahertz. The Atari, I think, is clocked at 2 megahertz. So, well, I guess I shouldn't have expected. Yeah, if you'll remember, I put the Franklin's CPU in the Atari to see if it would do anything, although I guess now that I think about it, I shouldn't have expected that to work necessarily, because the Atari, I think, is clocked slightly faster. Anyways, so I have put the 6502 back in the Atari 400. So, but it is Apple II July, so that, well, that's the only mention that's going to get. Well, that leaves me with a dead processor. What do you do? Well, you could order 6502 processors from UT Source. You could also get an email from them saying that your 6502 processors you ordered are out of stock. Here's our replacement new part. It's only $20 each. No, thank you. The used ones were $3.50. And actually, the only reason I ordered them was for science. Although little did UT Source know that I got more entertainment out of their really expensive price for the new parts, which are probably most certainly remarked parts anyways. Although, also, I think the funny thing is the apparently these processors that I'm actually going to use. Yes. I'm glad Joe's here in case I start to screw up on this. I will do something special with the dead chip, but I found it hilarious, and I just broke the seal, so now I have to mount these within 1 year. Of course, that's if I'm actually soldering them. But anyways. But, oh, okay. Yay! 60% is blue, so I don't have to bake them, although I don't need to bake them anyways. For only $10.75 each, and I ordered 2 just in case, I have brand new 65 CO2s. Now, the thing is, you cannot just jam one of these in the socket because the 65 CO2 has a couple of extra signal pins. Yeah, the CPU adapter board would not work for the Franklin Ace. I do not believe it would, because the Franklin Ace is a clone of the Apple, and the adapter boards don't work with the Apples because of the, I guess, when they designed the Apple II, it really was making use of strict timings. So it looks like I gotta move these the other way. So I'm pretty sure that I'll have the same problem in the Franklin Ace as the Apple II with those adapter boards that have the transceivers, because of the timing that the Apple II and all of its clones expect. Oh. Well, if you want to send me a 6502, Adam, I could. I'm going to make a video about this, and I actually could use an extra working 6502 for the video. Because after UT Source admitted, or told me that they were out of stock of, I don't remember. I told UT Source that no, just refund the part of my order that's out of stock and ship everything else, because I wasn't about to pay $20 for a 6502. Anyways, one thing you can do, but you got to do a slight mod, is you can replace the 6502 with a W65CO2, and this came direct from Mouser. This is the package I was supposed to get last Thursday, and it never arrived. I don't know if those adapters work in any Apple II. But Jeremy, your Apple IIc is a little bit different, because I think the Apple IIc actually uses the 65CO2, and I would have to look up the differences between the 65CO2 and the W65CO2, which I'm looking for my chip lead straightener, which I put in the wrong drawer. No wonder I couldn't find it. So before I do this mod, but we'll take a look at what's in your box and figure it out. Yeah, okay, so we'll still need a mod of some sort, but it's different than the. So the difference between these two, and actually, that is exactly what I meant to bring up here. Actually, the really cool thing is, if you go to the Western Design Center's website, which I'm going to attempt to do here now live, because bringing up websites live is so much fun. And you can actually go to their application notes. And they actually have a really nice page that you're probably not going to be able to read at that zoom level, so hold please. Come on, Firefox. I know it's Monday. There we go. So they have this really nice application note for replacing various 6502 processors with their W65C02. And on this page, they actually have a pin comparison chart between the 40-pin DIP processors. I don't get exactly why they changed it either, but they do attempt to explain themselves here in their comparison, that they added some new things for low power and better response, and yeah, I wish they didn't change it, but anyways, so the pin comparison chart here kind of shows the differences between the W65C02, which is going to be this column here, and the 6502. So on the 6502, pin 1 is VSS, which is ground. Pin 1 on the W65C02S is VPB, the vector pull, and it is active low. So we don't want to connect pin 1 at all, because otherwise we are going to have issues. So pin 2 is this, it's ready, but on the W65C02 it's actually bidirectional. However, I've checked the Franklin Ace schematics, and it has the same pull-up scheme as the Apple IIe, so I think we're good. I don't think I need to do anything about pin 2. All right, pin 3, even though it's got a different name, it is actually the phase 1 out. They just, I guess their engineers got tired of typing that funny character, so therefore they called it PHI10 for out. It's the same thing. We don't have to worry about that. Pin 5 is the memory lock output pin, which we is that one we've got to worry about. Actually, I think that's a no connect on the Franklin Ace. Okay. This one is a really important difference. Pin 36 is bus enable. It is active low, and on the Franklin Ace, it is a pin 36 is a no connect. Therefore, we need to tie this pin to plus 5 volts to make sure that bus enable is not floating and occasionally disabling the bus. And then pin 37, I think they named the output. That's the same. And then pin 39, it's just a renamed pin, it looks like. Yeah, I did pull up the schematics on the Franklin Ace, and I am going to double check that the no connects actually are no connects. Joe warned me that you just want to make sure, because sometimes on some of these systems, engineers would use the no connects as a convenient way of routing signals between layers of the board. So we will need to double check things. But as I did look at the schematic, and it looked like everything that should be no connects is, at least on the schematic, marked as a no connect. So I am expecting for the mod, and I've got Joe's directions somewhere, but so let me go back to table cam so I can pull up Discord, because that's where I've got Joe's directions. Oh, no, Discord, I appreciate your grand offer, but not today. Let's see here. Blah, 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 blah. Actually, I think that is... All right. So, Joe's instructions are for this mod, and I'm pretty sure Joe did this to like an Apple IIe or something, and the Franklin Ace is close enough. We need to raise pin 1. Ensure pin 36 is floating on your Ace, and if so, then connect pin 8 to pin 36, done. If pin 36 is pulled high, do nothing. If pin 36 is pulled low, raise pin 36, then connect it to pin 8. So, in order to double check these signals, I do need to... Ooh, that screw is stripped. Okay, I kind of would like to look at the back of this board, but there is a stripped screw. Thanks to someone who worked on this before I bought it. But that screw right there is stripping out. So therefore, I'm not going to try to remove it. I'm going to instead just look at the top of the board to see if I see any... Actually, here's what I'll do. I'll just make sure that the... All right, let's see here. Ohms, relative mode, second, whatever that button is, print, auto, and yay. Oh, wait, nope, I moved that program to the desktop. All right. So let's double check here. If I look at the pinout, so I'm going to do the other thing, and that is, so that's pin 40, 39, 38, 37, 36. Pin 36 tied to ground? Nope. Pin 36 tied to any of the voltage rails? I don't think it is. All right, looks like it is floating. All right. Yes, congratulations, Adam, for finding the correct screws. Hopefully I can find the screws for this. All right, so all I need to do is, so I need to raise pin 1. Actually, I'm not going to do this over top of the motherboard because I will be soldering here in a moment. So, going to raise pin 1 using the Thomas. You know, usually, I know that is probably going to, yeah, some people are just going to be cringing now that I got a pin that is just they're like, no, I don't want, that's not what you want when you put a chip in. But yeah, for this chip, we do need to lift that pin. I probably will put just a little bit heat shrink, although I bet this heat shrink won't shrink small enough for that pin, so nope. Okay, I won't put any heat shrink. So pin 1 is lifted because we don't want that to be connected to ground because it's an incompatible signal. Now, I need to solder a jumper wire between pin 8 and 36. And you know, I just clipped these nice leads off of the RIFA caps. So, one, two, three, four, five, six, seven, 8. Actually, I think I could use some. Oh. A magic helper here. Oh. All right, and let's see here. Let me go ahead and see. 1, 2, 3, 4, 5, 6, 7, 8. All right, put a little solder there. And we now get tweezers because solder are hot. And I can't. See if I can't solder that, and I'm probably going to have to put a little flux on it. Is that? All right, I'll clean that up in a moment. All right, so we got pin 8 to pin 36. And pin 36 is going to be, hold on, let me get this arranged so that we can both see it. All right, maybe 40, 39, 38, 37, 36. I want to bend this wire over like so. Bend it down and all right. Now, that is not the prettiest mod in the world. In fact, actually, I think that, oh, actually, that did worse than I feared. That wire's too, okay, that was a bad thing to use to do that. So let me clean up that pin and see if I can't find a wire that's not as... This is also why I bought 2 of these, in case I mess the first one up. Yeah, I'll have to find my 30 gauge. I have 34 gauge. All right, let me clean that up. If I can find the solder braid that I sure thought I left on my desk, even though it's supposed to go back in the toolbox when I'm done. There it is. All right, and let me get the other blob off the other side, and then I'll put that in the pin straightener, and hopefully we will be back in business. Well, I can get the solder that I got on the... There you go. Yep, this is one of the new 65 CO2s, or W65 CO2s. And I'm trying to mod it to put in the Franklin Ace. At the moment, I am doing a wonderful job of breaking it. All right. Let me see if I can't find some better wire to use. Yeah, that 34 gauge bell wire might not be too bad. Oh, this stuff's probably fine as well. It's not as stiff as that RIFA cap leg. Let's see here. It's some gauge of wire that I don't remember what it is. All right, I think it's 24 gauge. All right, let me also see if I can't... Also, I'm going to see if I can't maybe form this wire before I solder it so that I don't stress the chip again. Well, there's pin 8. I am going to cut this short because that's too long, but let me at least get this formed. And then, let's see, there's pin. All right. Actually, I need a little less. Oh, I thought I'd leave some of the insulation on. Oh. All right. All right, so there is, so that goes, if that goes to pin 8, then Yes, I am going to make this new chip do old tricks. Or I will thoroughly destroy it in the process and have to pull out the second one. Or I will get frustrated with this and I will design a adapter board. Because actually, actually, I think there is an adapter board already made. It's just I would prefer to order boards from a different... Oh wait, that's right. I think I did finally find the GitHub for the project. I was having there are several different adapter boards, and I need the one that does not have transceivers on the board. Which I would be interested to know why the transceivers are on some of the adapter boards, because I've looked at the datasheet for this processor, and it looks like it works at the same voltage level that the old chip works at. So I'm curious why there's adapters with transceivers, because this chip is, I mean, it works from 5 volt to all the way down to 1.8 volt, but it is 5 volt compatible. I'm sure this gets easier the more you do it. All right. So, it might be easier to do it with the chip in the socket, but I don't want to get solder in the socket. All right, I think that wire is where it needs to be. Yeah. Yeah, I know. Everyone's in the chat saying, put it in the socket, put it in the socket. I don't want to get solder in the socket, because I might replace this with an actual 6502 someday. Well, I'm not sure that's the prettiest looking soldering job, but it is soldered. Then just replace the socket. Yeah, no. All right, I think I guess I was trying not to have to just simply replace the socket, because Franklin used dual wipe sockets. There we go. Looky there. That's a totally legit W65CO2. Oh. Ah! Thank you, Joe, for filling in for Jay's role while Jay is at work or cleaning his office or something. All right, and then this processor now can just simply go into this socket, and it, wow, is just going to I guess I could clip that pin, but yeah, if I replace the socket, I could put the wiring under the socket. That is true. But I was trying not to. I guess I was trying to do the minimum amount to wrap up repairs on this. I might consider it, but I thought it would also be nice if I could swap CPUs in this, because it's at the moment my only Apple II compatible. Throws hint at somebody. All right, so got the power supply, we got the safety caps in it, we've got the totally legit looking processor that would totally, I feel like this is like something you would see on Action Retro, but he's not here to mention that. Hi Eric, hi Big Bad Biologist, welcome. I have this totally legit looking CPU. I mean, really, who in the chat is with me in thinking that this is something Sean would totally do? All right. Let me see if I can get my capture card to cooperate with me a little better than normal by first opening the preview window and then switching to the input and then turning this on and then probably seeing that it has shrunk or blown it up to some completely unreadable resolution. That's not good. All right, let me double check. Pin 1, 2, 3, 4, 5, 6, 7, 8. To pin, yeah, this is what it does. And that's pin 40, 39, 38, 37, 36. Yeah, it no likey what happened. It doesn't. Yeah, it does not like that one bit. I guess one thing I can check. All right, so let me see here. I could definitely use the pinout. I just want to check some voltages here real quick. So pin 8 should be, I think that should be 5 volts, and that should be, wait a minute, that's not, hold on. I need a pinout of the processor. Let's see here, processor. Documentation. Need a pinout of the 40-pin dip socket version of the processor. And an easy to read, I wanted pin 21, not pin 20. Okay. Well, that's not good. That should be 5 volts. All right, well, let me double check the power supply really quick. All right, that's 5 volts. That's negative 5 volts. Negative 12. 12. 3.8 volts. Yeah, that's kind of low. Surprisingly, the chip's not running hot. Yeah, that is, it does not like that. It does not like that one bit. And actually, I think with that mod on it, I am going to have to use, oh. Oh. I guess let me double check one thing here. So let me make sure that there's actually continuity between these two pins. This is actually an excellent use for that, and it's off screen. All right, so let me check, because if the bus enable was not enabled, then it would probably look very much like it does here. All right, so it looks like those two pins are connected. Test the voltage with the chip out. Yes. So let's see here. Pin 21. 1, 2, 3, 4, 5, 6, 7, 8. 3.2 volts. It's a fluke meter. As in, it's for metering flukes. Trying to think, is there a way I can test this processor? Yeah, check the entire Franklin for hot chips. Yeah, I'll turn it back on here in a moment. I guess I could put the processor back in. Well, okay, let me do this. So let me take the, let's make sure I didn't do something like totally stupid. I could also look at the schematics for the Atari 400 and see if it would work with the modded CPU. All right, just to make sure I didn't do anything like totally stupid, let me put the known working processor in. And actually, then I guess I could put the modded processor in the Atari 400, although I will have to check the pin 36. Yeah, I got I got bad mojo, Joe says. Yeah, I would agree. I got something is pulling the bus down. And that is a regression from previous. Whoa, whoa. I don't like how, they're not like hot. So hot I can't hold my fingers here, but I don't like how warm those ROM chips are. Yeah, let me check for solder balls in the CPU socket. There shouldn't be any because I didn't, well, I didn't, that's one reason I didn't solder over the board. Luckily, there's only 2 pins there could be. All right. No and no. No solder balls. Deoxit. Who's got the deoxit? Oh, all right. We're gonna go for not the deoxit, but because it looks like the power supply is putting out the correct voltages. So my replacing the safety caps doesn't appear to have done anything there. Maybe I will try reading there might be an extra 40 pin. Oh. Jeremy, that was, if anyone saw me joking on Twitter that I might have forgotten to order sockets, normally I do forget to order sockets. I ordered 40-pin sockets with those processors. Yeah, I know, Joe. But it works for Adrian Black all the time. Although, not with that problem. Yeah, at Joe's, it says, deoxit isn't going to make 3.2 volts suddenly become 5 volts. Yay. Yeah, I got to find the... All right, so what would cause 5-volt line to be pulled down to 3.3 volts? A bad chip would do that. A bad capacitor could maybe do that. A bad resistor, actually a bad anything could probably do that. Because I know I've got 5 volts coming out of the power supply. Although I guess I'll double check that. So, all right. All right. So I'm going to Okay, I definitely know I will have some of these voltages are going to be high. That's fine. That's 13 volts. Without a load, that's fine. Okay, negative 12.3 volts. Negative 5 volts. 5.7. Okay, no load. Okay, no load. That's fine. All right. So I've plugged the power supply back in. All right, 5 volts. Negative 5 volts. Negative 12 volts. Hey, Dave. 12.7 volts. Okay, I still don't like that 12 volt, but I don't have the floppy drives plugged in, so I think the floppy drives are the main user of 12 volts. Probably fine. Power supply is good. Don't beat yourself up, Joe. It's probably a coincidence. I don't think your suggestion is what killed this. I probably had a marginal chip on this to begin with. So it looks like this Franklin Ace just doesn't want to leave my workbench. Jeremy's going, no! No, no Franklin Ace, bad Franklin Ace. Start working for Justin so he can get to my project. All right, this is kind of where I wish I had one of those thermal cameras. Because, all right, the hottest components are the ROMs. Joe, it's actually, I think, it's doing the same thing with the other 6502 that was working. So I think I've had a chip go. Okay, I'm going to do something. Yeah, Joe, I think we think alike. I was just about to say I'm going to pull the ROMs because there are two reasons. First, to see, just as Joe said, see if we get 5 volts again, and hopefully not mangle the pins so bad. Second, if I think the ROMs, one of the ROMs has gone bad, I can read it. And yeah, actually, I found a little thermal camera that it's like an iOS attachment for an iPhone, and it was only like $149 or something like that, which for as often as I would probably use it, it looked like it would work just fine. All right, I am very carefully setting these ROM chips in order. I don't have a quick read thermometer. All right, I am just... All right, I don't know why these ROM chips don't want to pull straight up. Okay. All right, this Franklin Ace is definitely not going to do anything different. All right, I know you can't see the screen, but I can tell you that the output from the screen is no different than it was 3.8 volts. That's not the item pulling the bus, pulling it down to 5 volts. Although there is another ROM on the board. Yeah, the screen will be the same. Yep, I know, because the ROMs are what clear the screen. Or I guess the ROMs are what clear memory to then have a blank screen. All right, I just pulled the other ROM, that's on the board. It wasn't feeling hot. This is the, I think, the character ROM. But, oh, lovely. Yes, if you couldn't tell, it was the, well, I'm up to 4 volts now. Check the buffer SE and the left side of the CPU. Okay. Yeah. Well, I don't think it was any of the ROMs. Or definitely not the character ROM. Although, with the character ROM pulled, we were at 4 volts. But the character ROM was not getting hot. And the fact that I was seeing an @ symbol leads me to believe the character ROM is not the culprit. So I'm gonna go ahead and put it back. All right, the buffer SEs. Yeah, all right. You know, this is the funny thing. Yeah, I think there's 3 buffer SEs. Unfortunately, if they are defective, I don't think I've got anything to replace them. Because actually, we've been here before. If you'll remember, when I had the bad CPU, I actually pulled these buffer SEs out and swapped them around and determined I had a bad CPU. Of course, what if the whole problem was the... Of course, the thing is, I don't think I ever measured the voltage on the CPU, because I don't think I got that far. I got it working with a different CPU. Okay, I'll try that. Let me pull these finish pulling the buffer SEs and check voltage. Otherwise, I'll get some isopropyl alcohol out and... I do know, I think these buffer SEs... Yeah. I'll take these out, I'll check the voltages, and... I guess I'll leave the ROMs out for now, because I think with these buffer SEs out, we're not... the ROMs are a moot point. Why do I keep hiding my pin straightener? I don't know. Because I keep bending these pins trying to pull them out, because I need a better chip puller. Okay. .7 volts. Yeah, there's still something pulling the bus down. I mean, I feel some of these chips are warm, but... not hot. Yeah, okay. Let's try some isopropyl. All right. To minimize the spillage, I just put some in a bathroom cup. going to kind of... Oh, wow. It evaporated off of those chips pretty quick. Those chips don't feel warm, but the isopropyl evaporated off of them fairly quickly. I guess at least one good thing is the, yeah, I'll have to pull up the schematics. Of course, maybe I'm not getting a uniform amount of isopropyl in these chips. At least the RAM chips don't seem to be getting overly warm. Wait a minute. All right, I realize this is off camera because this board's just too big. I can't practically turn this board around so you can see what I'm doing because otherwise the power supply would be floating in midair. Okay, there's some LS161. Yeah, I'm just going to finish this experiment and then I'll actually pull up the schematic and see what some of these logic chips do. Well, now that's interesting. Whatever LS51 is, the isopropyl stayed on it quite a while. Oh wow, that chip is actually, that chip's not getting even slightly warm. Yeah, I may just have to remove them one by one. That'll be so much fun. But I guess I'm probably going to have to do it because this is not the direction I thought this repair would go in. And where is my chip pin straightener? I keep misplacing it. I guess I'm just going to have to get one in bright orange so that it cannot hide on my workbench. Do I keep putting it back in the drawer on myself? No. All right. Okay, well, that's the Atari 400 CPU and board. It's not under there. It's not in my pocket. That would be too easy. It's not under the... Oh, there it is. All right. I found it. It was... Yeah, I think Joe's right. I think I'm just going to have to find the short first. Or the long. I guess I could find the long too, but I don't think that'll help much. All right. All right, I don't think those chips are shorting, and I don't think the ROMs are shorting, so I'm going to put them back in their sockets. Mainly because I only have so many places to put chips. That need to be kept in a certain order. And I don't know that these ROMs are... Well, I guess they are all labeled. They're just not all labeled the same way. All right. Well, I guess one thing I could do is just... That would be embarrassing, but... Oh, just making sure that I didn't somehow have a screw hidden under there. Okay. I guess I'm just going to start methodically pulling chips. All right. The first thing I'm going to do is I'm going to look at all these chips and I'm going to see if any say MOSTEC on them. Unfortunately, I don't think any do. Because if there's any MOSTEC chips on this board, then they're going to be the first that I pull to see if there are any shorts. See, there's a lot of Texas Instruments chips. Let's see, I do see a couple chips I don't recognize the brand. Let's see, that's Hitachi, Texas Instruments. Let's see, that's Motorola. SB, SA. Those might be PALs or something. So I'm first just going to... I'm going to pull the chips that I don't recognize the brands and see if they're shorted. I'm more likely to believe the Texas Instruments and Hitachi chips are good, although it's no guarantee. But there's a lot of chips here, so... All right, there are no MT RAM chips on it, because that would actually have been the very, very, very first thing that I would have done. But they are all Texas Instruments chips. So I am first going to... Of course, I just had the thought, maybe I should try pulling the memory chips one by one first. Maybe I'll go with my original plan and pull the chips that I don't recognize the brand. All right, I think that's Texas Instruments. That one's, I think... Well, I don't recognize the brand, but that one's also in a really weird spot, so I don't think I'm going to be able to get that one out. Texas Instruments, Motorola. We already tried those. Okay, I'll have to come back to that one. It's at a weird angle. All right, so this one, I don't recognize the brand on it. On the board, it says it's a 9334. I'm hoping that doesn't mean it's some type of PAL chip, which might be why I don't recognize the brand on it. All right. All right, 3.9 volts. That's not it. Texas Instruments, okay. Here's another one of those chips. It's got an SA on it. All right. .9 volts. All right, that is not the chip. TI, Motorola, TI, Hitachi, TI, Motorola. Those are all TI memory chips. TI, Hitachi, TI, Motorola. Squiggly lines, I think that's National Semiconductor. I think. Their old logo. I might pull them. Okay, so that was another one of those chips that just has some generic marking on them. Oh, I think whatever chip I just pulled now has to do with video. 3.9 volts. All right. Yeah, I bet that's in. All right. Yeah, I think I've seen that mark on chips. I just don't recognize the company. All right. TI, Motorola. I know I'm off the board, but it's kind of a. Oh, that's Texas Instruments, TI. It was a lot. Franklin got a lot of chips from TI. Okay. Okay, so that. Yeah, Franklin. I have to admit, a lot of the chips on this board are name brand chips. So I guess good job, Franklin, for not like cheaping out and buying only the cheap chips, which would have been MOSTech for sure. All right, I'm gonna. The next thing I'm gonna do is the RAM chips, one by one. And then if that doesn't, if I don't find it there, then I will just start pulling 3.9 volts. Nope. Hey, Jeremy, remind me which memory chips we ordered. Were they 4164s? Actually, I'm just going to pull all the RAM chips. Pull all the RAM chips and try not to destroy them, but... Because I know I ordered one for you, and then I ordered one for me, but I don't remember what memory chips they were. I've ordered too many chips this week. Yeah, it uses 4164s. I'm just going to pull all these memory chips and then measure the voltage. If I haven't brought those memory chips down here yet. If I had them down here, then I would just be able to go look at them, but they're still upstairs. I have to admit, when I saw how the seller packaged them, I was actually kind of surprised there wasn't a the Postal Service has opened your package for inspection label on it, because they sent the memory chips in the original tubes, wrapped in aluminum foil, packaged in styrofoam, wrapped in plastic wrap. Which I for sure thought, well, maybe it's probably because the Postal Service didn't x-ray the package, but I was for sure thinking that I am surprised the Postal Service did not inspect this. 3.986 volts. Nope, that is there 7805 on that board? I do not believe so. Because yeah, if there was a 7805 on the board, I would for sure. Okay, so it wasn't any of the RAM chips. They're yeah, I guess at least that's one good thing that maybe Franklin didn't exactly copy Apple chip for chip, although I think they did in some of their earlier ones. I think by this point they, because actually there's 64K of RAM on this Franklin. I suspect if I had a DOS 3.3 boot disk, I'm actually expecting that when it boots, it would load Integer Basic into the language card, because I suspect that's how Franklin set up the other 16K. It probably looks like a language card. So I guess at least one good thing is they cost reduced by simplifying some of the chips, because right there's I guess the chip that Franklin used in place of some of the floppy logic chips. It's almost like they had an integrated WAS machine before Apple did. Although maybe not. You know, I'm just gonna start, here's a chip, it's right beside it's near the power connector. Maybe it's, I don't know, I'm just gonna start methodically going through the chips in order now. Because it's not the RAM. It's not the RAM, it's not the chips that I don't recognize the branding, so now it's time to, oh. First of all, it helps to not reverse the probes. Well, we're up to 4 volts. Oh, wonder if I have, oh, that could be really, really. Actually, let me do one other thing as I'm pulling these. So let me find the program for my TL Mini Pro that looks like I've unplugged it, so I'll have to go plug it back in. So for any of these logic chips that my little TL Mini Pro supports, I'm going to run the check on them. All right. So this was a 74 LS368. Which is not supported. Okay. All right. Unfortunately, I'm getting the impression it could be more than one chip that's bad, but for now, I will proceed with I know what I'm going to actually change tactics. 74 LS08. All right. I am going to start in order of chips that I can actually put in the Mini Pro and test. So that at least I can get a 2-for-1. Check voltage with it removed, and then actually check operation of chip. Wow, an integer basic card. That seems like that might be pretty rare these days. I did just about order a language card, but then when I realized there was actually 64K of memory on this Franklin Ace, I decided to wait until I could boot DOS first to see if its extra RAM acted like the language card. Because there were a few that looked intriguing. All right. That chip tested good. Oh. All right. Even if the chip tests good, I'm still going to check voltages. All right, 3.9. Nope, that's not it. Although I suspect if it tests good, then it probably is not guaranteed. I guess it could test good, but be drawing more current than it should be. Okay. Yeah, yes, I will run Computer Inspector gladly, because I would be curious what it thinks it is too. All right, I'm looking to see if there's any more 74 LS08s. And then I will go to, here we go. There's a couple 74 LS08s. Just because the Mini Pro can test them. If someone has a suggestion of logic chips that are more prone to go bad, then I would be, otherwise I'm just going to systematically, all right, 3.9 volts. That was not it. All right. I am wondering, I am kind of beginning to wonder that too, but let me that if it might be a passive component. Unfortunately, that could be a bit harder to measure, although if someone could pull up the Franklin schematics and let me know which of the capacitors are on the 5-volt line, I could measure voltage at each capacitor and, well, actually I could measure. Actually, I don't necessarily need to know which ones. All right, that one's on the 5-volt line. That one's on 12-volt. 555s, I'll check those. Let's see here. That one's on 12-volt. I'm checking capacitors. That one's on 12-volt. That one's on 5-volt. So actually, interestingly enough, the capacitors on the 5-volt line are reading 5 volts. So that. Okay. All right, Adam, good night. Thanks for joining. All right, I will, actually, let me check the 555s here. In fact, I bet the Mini Pro can test those, so. Oh, actually, I bet it can't because those are not discrete chips. Never mind. Well, I can at least pull them and, all right, there are 2 555 chips, and I'll go ahead and just pull them both. And I thought that if Adam decided to give 30 more seconds of watch time just to see. All right, well, the screen is still garbage. .9 volts. Decoupling caps can turn into resistors, measure voltage at the caps themselves. Well, that's what I was doing, but I was using the common, well, actually, there were a whole bunch of glass capacitors on this board. And I don't, oh, are these glass capacitors non-polarized? Oh. Okay, that one's on 12 volts. That one's on 5 volts. All right, I guess I can go through. Okay, I see. Yeah, I don't know which is positive and which is negative without necessarily checking. It's kind of hard to tell. I'll check these glass caps. 5 volts. Oh, hello. CC2 is reading 4.3 volts. That's... CC1 is 4.3 volts. CB2 is 4 volts. I'm going to have to pull up the schematic here. Because I think I might have... CRB1 has no voltage across it. Okay, CB1 though is 5 volts. All right. So actually, I think I might have an area of the board to look at. Or maybe one of these glass caps is. CB4 has no... Oh, I've got 2 chips pulled off the board. Measure voltage, or check them when the power is off. Oh, yeah, I could check the resistance. But I found a part of the board where voltage is not 5 volts, so I just need to pull up the schematic and see what part of the board it is, because that might be an indication of where the logic chip is that's pulling the logic down to 4 volts. All right, but I guess I can. Okay. All right, so I have, okay, I guess let me check the capacitors. That no multimeter, I really would like you to go to relative mode and there we go. All right. I guess maybe the could be leftover from the keyboard short. Yeah, it could be. Although the thing is, I actually was able to get the computer to boot. You know, that's really weird. All right, so that ceramic cap is 154 ohms. That seems pretty high. But this ceramic cap is open. This ceramic cap is open. This ceramic cap is open. And this ceramic cap is open. That's not good. All right. Yeah, maybe. Yeah. The funny thing is though, so yeah, shorted the keyboard. I fixed the keyboard. It was working. I actually came down, I think it was Friday or Saturday when I got the floppy drive belt, or found the floppy disk. I actually got the Ace to try to boot. And that was, I think, after the keyboard short. Yeah, that had to be, because I couldn't find the floppy disk that stream. So I guess it could be a slow failure. Yeah, leftover issues from shorts can be fun. All right, let me pull up the schematic. Let me see if these capacitors are where these capacitors are in the schematic, because well, I need to know where they are in the circuit, as well as what value they are, because I don't know how you read them. A glass cap. And then I'll probably want to see about, let's see here. Let me download the PDF. Yeah, at some point I will do a full recap, but since there's no recap kits for this computer, I'll have to find caps. But the thing is, normally when I do a full recap, I don't replace the ceramic caps. And glass caps are kind of in the same boat as ceramic in my mind. Although, it's possible I did damage them when I shorted the keyboard, so... Yeah, one of them did show resistance. It was about 150 ohms, but the others were open. So I think some of those may be blown. I'm just trying to figure out where they are in the schematic so that I don't go on a wild goose chase. And also because I'm hoping the schematic says what value they are. Unfortunately, the schematic is hand-drawn, so it is not... I can't search the component references. So instead, I just need to find the page that looks like a... All right, here. I think this is the page I want because I think that is... Oh, wait, no. I don't think that's it. ZH12. No. Oh, wait. Maybe this is the right page. Okay, I don't know how in the world they came up with some of their component references, but... Oh, no. Okay. JH2. So I'm looking for CB1, CB3. Where is the keyboard connector? Keyboard connector is CD8 or thereabouts. Yeah, they're probably small. It might be 0.022 microfarad. Let's see, there's CE. All right, I'm close to the right page here. Almost. Unfortunately, this is not searchable. But I'm seeing components with familiar names. Let's see, B8, B, E, C. All right, I think I found the right page. Of course, I'm going to say that several times because... Nope, that is not the page I'm looking for. C, nope. Maybe I should... You can see what fun I'm looking at. Wait a minute, there's CA6, CA... Oh, I don't... I think I'm close. Wait a minute, no, that's a signal name. Never mind. RJ1. Nope. That's the completely wrong side of the board. Those are the transceivers. That's all up. All right. Oh, let me look this note. All caps are 0.1 microfarad, 50 volt, unless marked otherwise. Okay. That's good to know. So ZB28 is a pin 8 of an IC at PC board location B2. 3ZB82 is pin 2 at an IC at PC board location B8, shown on sheet 3. Okay. All right. RB1 is a resistor number 1 in PC board row B. CA3 is capacitor 3 in PC board row A. So, to find those capacitors, yeah, all right. Unfortunately, the name is not as useful as I thought it would be. I think they are on this page of the schematic, because this is the keyboard connector. If we are assuming that I made a, well, we know I made a mistake, but if we were assuming that the mistake I made caused collateral damage, then this is probably a good place to start looking on the schematic, and I think I see the capacitors. So there is C... Nope, 5, 4. So I'm looking for CC1 and CC2, because those are the first two that are reading as open. And CB2. And they are near the 555 timers, so but the way this board is laid out, that seems to be an unsafe assumption that just because it's beside a component doesn't mean it's in the same area of the schematic. And unfortunately, the traces are, it looks like the traces for those capacitors are going onto the board, so I'd actually have to, oh, this PDF is searchable? Did I make an assumption based on the fact that it looked hand-drawn? C1. Well, that's not the right page. A good cap should show as open. It's low ohms, not open to look for. Okay. All right, these capacitors are going to give me headaches. So, CC2 was open. CC1 was open. CB2 was open. CRB1 is open. CB1 is 158 ohms. So I guess I'm actually looking for CB1 in the schematic, but not the schematic for the monitor. All right. Yes, this would appear to be searchable, but it also would appear as the component I am looking for. Well, okay. Let me see. CB1. Not found. All right. Oh, well, here we go. I can at least confirm the value of it. CB123, so that is a 0.1 microfarad 50 volt mono glass, whatever that is. Okay, so that's a 0.1 microfarad. Let me see. I think I've got some on the work. Yeah, CB1 might be the bad one. I think I've got some ceramic caps. Here we go. They're 0.1 microfarad ceramic caps. I would be curious. So if I take one of these, oh, I am screen sharing. All right. So if I take one of these and I measure its resistance, because I know these are brand new caps, so okay, if I take one of those capacitors and drop it on the floor, and then take yeah, these are ceramic, and take another one because I dropped the first one on the floor and don't see where it fell. Are these really? Oh. Yeah, okay. It's an open. All right, I guess that glass cap is, oh, there's the capacitor I dropped. Oh. Kick it over to where I won't roll over it with the chair. I'll pick it up later. So I still would like to figure out what circuit that's in, although maybe that is the source of the voltage drop. I guess I could. Well, one thing I could do, because it does look like it's bad, I could clip the one leg and bend it up so that I could at least power up and see if the voltage drop goes away. Unfortunately, I've got a stripped screw to contend with. I don't know. Don't know if I will be able to get the screw out with what I have available tonight. Because I think I need to buy a Dremel. What IC is it on? I'm still trying to figure out which IC it's on. Because the other thing is I could also pull the chip. Well, I may have more than one, but okay, so I did find on the schematic where a whole bunch of the filter caps are, but CB1 is not in this list. So I'm still looking for where CB1, if it was in this list, then because that's off of plus 5 volts. Let's see, that's plus 12 volts. So actually, that's going to be off of one of the chips. So I still need to find, I can't see the trace because the trace is on the bottom of the board. So I need to find it on the schematic, because the other thing I could do, if there's one chip that it's connected to, I could pull the chip. And that would also be a quick way to see if the voltage drop goes away. If it's on more than one chip, then I'll clip the lead, as it looks like it needs replaced. I really wish I had some axial ceramics to replace it with, because I really don't like the way radial ceramics look when they're in an axial part position, but I already placed my Mauser order for the week. But maybe if anyone saw my Twitter message today that I inevitably forgot something like sockets or capacitors, well, ding, 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 ding. Looks like I forgot to order some capacitors. Because that probably was in the back of my mind that, you know, I wish I had some radial or wish I had some axial ceramic caps, even though they probably cost an arm and a leg and a left-handed drill bits. I don't have any left-handed drill bits. I will have to look at some. The low-value capacitor can be left out. All right. I mean, it really does appear to be a bad capacitor. Let me double check. 100 and... yeah. Okay. All right. I'm wasting time trying to find this on a schematic. They're cheap. So I just did it. All right. CB1 is no longer in circuit. I apologize that you could not see that, but it is like down at the very bottom of the board. So let's see if my mystery voltage drop goes away. Otherwise, I guess I'll check more ceramic caps down in this area of the board. Oh, it didn't beep. I probably have more than one. Oh, it would help if I was in DC volts and not ohms. .7 volts. No. That's probably not the only troublemaker. Or whatever chip that's connected to is also shorted. So if anyone, I'll put the link to the schematics if anyone would be kind enough to see if you can find CB1 on the schematics. And I'm going to check the other glass caps down in this area of the board, and then I'll start to work my way up. So I'm just going to check. Oh, that one's not, that's CD2. Well, okay. I really hate to just start clipping components, but if they're measuring 150 ohms, they're not good. They're bad. So and I guess ceramic caps are cheap. So wow. That's four. Before I go cutting too many of these, I'm going to, wow. Six, 7, 8. You know if Mauser sells them? 9. They probably do. 10. Wow, I have a whole row of bad glass capacitors. that doesn't seem right. How do... Does this board really have that many? You know, I may just have... This may be the first computer where I just have to do a full, complete, total, utter recap, including these glass capacitors, because either that or when I shorted the keyboard, all right. Yeah, I got like a whole bunch of... Oh, okay. Yeah, I'll try to actually... Let me do myself a favor here and copy and go to Mauser. I have nothing against DigiKey. I just normally order from Mauser. Oh, Mauser. Yeah, won't be ordering them from Mauser because Mauser doesn't have any in stock. After the ones I've cut so far, I've found like over a dozen capacitors that are still reading like 150 ohms, which kind of has me worried that I'm reading some resistor that's in series or parallel or something like that. All right, well, okay. Yeah, because basically I know you can't see what I'm doing because of where it is in the board, and I have no way of panning the camera, and if I push this motherboard any closer to the back of my workbench, I am going to start knocking things off. But I have, well, actually, I guess I could unplug it from power and video and hope that I don't lose the cables. I just dropped something. I don't know what that is. It looks important. Oh, it's a right angle pin header. Oh, it's the right angle pin header I pulled off a floppy drive. Okay. Check the caps I cut. Well, I only cut one leg of them because I didn't really want to commit to cutting both legs. Well, that one that I cut is actually reading open now that it's out of circuit, so I just clipped. And that one's open. I just cut two capacitors that are actually just totally fine, probably because there is a... the resistance was somewhere else in the circuit. So that's actually probably... I probably shouldn't clip anymore because I've already clipped two and they're actually fine. I suspect probably what I'm just going to have to do is... I may just have to recap, maybe just replace, because I know I've read that these glass ceramic or these glass capacitors can be, I don't know, they're long-term, they might be more failure prone than ceramics. Oh, okay, well, I see something here. So I'm just looking at parts, and I don't know if that's ink or what, but there's a black spot on that capacitor. Oh, wait. It matches a black spot on that capacitor. Actually, there's what looks like black spots on many of these, which I'm not sure that, which might actually be some marking on them. Yeah, I don't know if I should. Yeah, tantalums are more fun, they blow up. Then it would be obvious which one was bad. These. All right, I guess I'm back to trying to find where all right, let me plug this back in, because there was one of these glass capacitors that I read that I was reading voltages, and I saw that it only had 4 volts across it, or at it, so now I'm back to needing to find where it is in the schematic so I can find the chip that it's connected to. All right, let's go back to volts. All right. What? Well, that really doesn't look good. Now I think I got. All right. Certainly. All right, so I got 5 volts there. So at CC2, I've got like bad voltage. CC1, I've got bad voltage. CB2, I've got there's 4 volts there. Oh. So I need CC2 and CC1. I need to figure out what those are connected to. Because, and CB2. There's 4 volts at CB2. And nothing at CRB1. Although, interestingly enough, at the 2 I cut, I have 5 volts. Okay. CC2, CC1, CRB1. Let's see if I can remember that. I haven't tried pulling all the chips, Thomas, because there's a lot of chips, and I keep bending pins when I pull chips, so I would prefer to make educated guesses as to pulling chips and not pull each chip in succession. Because I think there's a, I think we can, if I can find where those capacitors are connected to, I think I can then make an educated guess as to which chip to pull. And that's assuming it's a chip and not a passive. But it seems like there's 5 volts at all the capacitors, so I'm thinking there's a chip. So CC2, CC1, CRB1. I'm hoping one of those will be directly connected to a chip. So, okay. Fortunately, those are not in the bulk capacitor list, so that should mean there is a chip that they are connected to. CC2, CC1, CRB1. I'll put that in the chat. So if anyone, CRB, if anyone has the schematic, those are the 3 capacitors. Yeah, I'm reading 4 volts at CRB1 and like really bad voltage at CC2 and CC1. So I think the first 2 of those capacitors I put in the chat are the ones I'd really like to find, although if you find CRB1, there's a voltage drop there as well. I'm hoping that those are going to be, they're going to be beside a chip in the schematic, and I will pull that chip. Or even if it's a transistor or something like that. I'm hoping that it'll be a chip, because I can pull chip. All the chips are socketed, so it'll be very easy to pull a chip. The transistors would be a bit more difficult, because I do see there is a transistor QC1. Well, okay, I found capacitor CB2. Here we go. I found CRB1. Oh, wait, CRB1 is a diode, not a capacitor. Oh, okay. CRB1 is an IN4148 diode. All right. So I have just enabled diode test mode. All right. So with the black stripe to the black multimeter probe, it looks like I've got 0.58 volts. And if I reverse these leads, I think I should see 0.7, 0.8 volts. Wait a minute. That's not right. If that really is a diode. Ooh, that diode's bad. CRB1. It's on page sheet 4 of the schematics, grid A6. It is actually conducting voltage in, yeah, it should be blocking voltage in one way, but it's actually, yeah, that's a bad diode. And that is connected to CB2, which is not one of the capacitors I was looking for. RB4, QC1. Okay, that's this. I see a transistor here. Oh, that's in the speaker circuit. And there should be an LS74 ZL13. Wait a minute. ZL1. No, that can't be right. How in the world is that really the chip it's... No. That can't be the right chip. LS74. Oh, that's not an LS74. That's a 368. Okay. ZL13. L13. This chip. There we go. So that diode is connected to pin 5 of this chip. The diode is clear down on the bottom side of the board. Yay for fun circuits. Also connected to the speaker. Okay, I knew that would be too easy. I pulled the speaker, if anyone's wondering. Okay, I knew that would be too easy. Okay, it is a short protection diode, but it looks like it's might not be a good protect. Yeah, it looks like it is a short-head diode or something. Okay, so let me see. I just pulled that LS74. I wonder if the Mini Pro can test it. Oh, here we go. It is testable. Test is normal. I should have known that would be too easy. I may have to remove that diode from... I may have to clip the diode. I may have some, but 3.9 volts. Yeah, I think I've got some. All right. I've got to remove the diode from circuit because I think it's... I think it's bad. All right. Well, I've got some somewhere. There's a... Oh, that's good to know. All right, I just clipped the diode that I think is bad. I do believe now that the speaker circuit will not work. I have pulled the chip. No, that's not it. Ah, 4 volts. Okay. Well, with the diode out of circuit, I guess I'm going to go back to diode test mode. Oh, that's weird. Oh, come on. .57 volts. That's not it. It's the diode's fine. Why did it look like it wasn't fine in circuit? I'm looking at the schematic and I don't see... Well, it's still suspicious. Okay. All right. Should be 0.7 to 1 volt in reverse, and it's, well, it is kind of reading low. All right, I guess let me put this LS74 chip back in. It's not the... It's not the logic chip that's... Well, you know, the one thing I didn't do... We'll see how hot this transistor's getting. It's connected to the speaker. I doubt... Oh, no. Nope, it's not that transistor. Yeah, transistor's not getting hot. Okay. All right, let's okay. So it's not the All right, let me look at things around this. It wasn't the speaker. I already tried that. Those 555 chips are not in that circuit. Here we go. LS138. That is at ZH9. H9. LS138. There's two. Okay. Okay, these are... I thought I might have pulled these already. Maybe I didn't. But these are going to the LS74 chip that is then connected to that diode. Hi, Retro Techie. It's not fixed yet. In fact, it's broken. It's broken more. That's an important part in most 8-bit machines. Which part? That seems like they're all important. I don't know what these are doing right offhand by looking at the schematic, but it does look like it's doing something important. And I'm going to pull both of them. And I'm actually kind of expecting there really to not be... Ooh, that's a really lovely picture on the screen. Hey, good night, Eric. Well, with those two chips pulled, that's what I see on the screen. So I suspect I'll probably still have my mystery voltage drop. Oh, well, it also helps to be in volts mode and not 3.9 volts. That is not the logic chip I'm looking for, but let me see if the 138 is supported by the... Oh, here we go. The Mini Pro can test the 138s. I would even, at the moment, go for finding a defective chip, even if it wasn't causing the voltage drop. All right. That one's normal. New channel logo. I don't think so on that one. I think I like my old channel logo better. It just kind of did look interesting. Okay, and that chip's fine. All right. Hi, Steve. For those of you just joining, the Franklin Ace 1000 has regressed in behavior. And I'm trying to find the source of a mystery voltage drop. I have clipped capacitors and diodes, and so far I've not found anything that's causing a voltage drop. I still would like to find CC2 and CC1 on the schematics because I think they're going to be connected to another chip that I can potentially pull. And I seemingly think that those two capacitors are going to be on the same page of the schematic somewhere. There's CC5 and CC4. It's going to one of the 555s. That's the keyboard connector. There's no capacitors on that, but I don't have the keyboard connected. There's CB4. That's not what I'm looking for. Be careful what you wish for, Retro Techie. You might get the opposite of what you're asking for. Okay. Well, now, Retro Techie, I never said anything about violence. I just said you might get the opposite of what you're looking for. Tenth contact up from the front. Oh, I missed your... 10th contact up from the front. Don't get, Jeremy, I don't get, you're going to have to elaborate what you mean by that. What would be the opposite of a G3 all-in-one power supply? Well, a photo of one would be the opposite. Or, yep, Steve, you are right. An eMachines E1 power supply. That would be the exact opposite of a G3 all-in-one power supply. That totally would be the exact opposite. Slot 7. Okay, slot 7. Tenth contact from the front. Oh, Jeremy, you're not referring to this thing, are you? This is a plastic peg to prevent you from inserting a card in the slot because of the onboard floppy controller. That is all that is. Although, or are you actually referring to the actual slot 7? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh. Yeah, okay. Yeah, that's the, that got me when I got this machine thinking there was a bent pin in the socket until I really looked at what that was, and it is to prevent you from putting a card in the slot. So, yeah, I am trusting that I mean, it looks like plastic. I'm going to trust that it is plastic. I have no reason to believe that it doesn't belong because it looks like it was quite deliberately installed. The service manual does not mention anything about it, but yeah, I'm pretty sure that is an intentional thing they put there to keep you from just inserting a card. Now, the service manual does say that if you need to put a card in slot 6 for floppy drives, then you have to disable the floppy controller, and of course, it doesn't tell you how to do that. But I would presume you just probably pull that chip right there, and voila, you've disabled the floppy controller. At least enough for purposes of using I guess, an Apple disk controller if you wanted to. I presume that plastic peg would come right out if I tried. But I'm going to keep that in for now as the don't do anything silly, Justin, card insertion preventer. And I'm still looking for one of those two capacitors. I'm actually now looking at the page that looks like it is the video circuit. Only because the character ROM is down in that area of the board. And you know, at this point, I am going to throw the screwdriver at the board. I am going to see if I can get this stripped screw out. Well, I did get it out. This is not quite the direction I wanted to go in this live stream of disassembling further, but at this point, I need to look at the bottom of this board. All right, yeah, I'm kind of now regretting not trying sooner and getting that screw out, because apparently it wasn't. I thought I tried it first and it felt like it was stripping out, but apparently if I just applied a little more pressure, then it would have actually come out without stripping. Use the iHammer Mini. Well, I do know one thing that kind of is slightly bothering me, that whoever put these screws back in this motherboard, there are like little itty bitty bits of fiberglass under the screws, like they torqued them in real good. Although that is probably not any indication of an actual problem, because it does appear as if the traces are not too close to these screws, but still, it is just a bit disconcerting. All right, so I'll have this board off. These capacitors, okay, the diode I clipped that I shouldn't have, if I can find my IN 4148s in a reasonable amount of time, and I think I know where they are. No, actually, I don't think I know where they are. Never mind. I was going to go ahead and replace it, but wait a minute. Oh, there is one more screw. Also, when trying to remove one of these, do make sure you have all the screws out. As in, if it feels like you still have a screw in the board, you probably do, so stop trying to lift the board. All right, the good news is there are no burnt traces on the bottom of the board. So when I accidentally shorted the keyboard last week, I did not short anything, although I do see something very weird. All right. But it's probably not anything I did, but all right. Let's set that to the side. Set this, well, I guess I can now clean this really good now that I've got it off. It's, can you tell where dust wasn't able to fall? All right. I am seeing signs that someone might have had this board out at some point. Because at a high level, there's a dark spot there, although I don't know that that's necessarily, it looks like, of course, maybe that's where I sprayed contact cleaner on the top and somehow it leaked down, but yeah, maybe that's where I sprayed contact cleaner because that doesn't look like flux. Anyways, the thing I noticed, yeah, it's going to be squeaky. Well, I'm trying not to do anything that'll cause me to have to ultrasonically clean the board because of the serial number label, although I guess I can really carefully remove the serial number label. But I think that's just a superficial scratch. But that's not what I saw. So it looks like between those two pins there, and maybe it's fine. Looks like the trace goes between those two pins and there's solder on it. So maybe that is, yeah, that looks intentional. So maybe that's fine. I have to say the solder mask on the bottom of this board isn't the greatest. Anyways, so this is the area of the board under where the keyboard controller is, and I guess the good thing is I don't see any damage on the bottom that was caused by me shorting the keyboard to ground. Redo every solder joint on the board. It might come down to that, but I don't know that that would necessarily explain the voltage drop I'm seeing. I guess it could. Oh, wait a minute. What is... Oh, that's just adhesive, I think. It looks weird there, but then again, it doesn't look like a lifted trace. It just looks like adhesive causing an optical illusion. All right, so what did I want to do? So because I'm having trouble finding where these capacitors go on the schematic, I wanted to pull the board out so I could see if I could see where these two capacitors, CC2 and CC1, go. Yeah, it won't fix it, but it'll extend the stream for a couple days. Oh, well, those capacitors appear to be in parallel. Because, let's see, so here's the one side of the capacitors, and then there's ground. So they're in parallel, and they're going to this 555 timer chip. Right. So they are going, it looks like they're going to that chip there, and I've already pulled it, and that didn't fix the problem. Oh, right there they are on the schematic. I completely didn't even see that. Yeah, sure enough. So they're, yep, ZC1A, which is, yeah, that one right there. So this is connected to, so there is an LS08 at ZG5. G5. Here we go. Oh. Well, I just spilled isopropyl alcohol on my desk. Luckily, I had the forethought of just putting a little bit out for myself, knowing that I'd probably spill it, and now I can't find the paper towels. Oh, that might be because I ran out down here and haven't brought one downstairs. Great. Oh, well. I guess it's a self-correcting problem. It'll just eventually evaporate. Okay. So, ZG, so that 555 timer connects to, actually, I think I've already pulled this LSO8 chip. If I were to follow the, although looking at the circuit, I wouldn't expect, I don't know that I'd expect that to cause the problem, but I guess I can, well, actually what I'll do, I'll just test it in the Mini Pro here, because the LSO8 is a supported component. All right, so LSO8. Tests normal. All right. Yeah, I don't, looking at the way the schematic is, I wouldn't expect a, well, now, I guess the one thing I could do, even though I pulled both 555 timers and still had the mystery power drop, I mean, maybe this one, maybe I should pull this one because that's the one those two capacitors are connected to, and then recheck the, which I will have to very careful. Now this is the point of the stream where actually that just okay, that's sketchy as all get out. So instead, I'm going to, hey, I get to use my new silicon mat. Because actually, I'm going to have to pull out all of my silicon mats to be able to insulate this motherboard from the desk. What do you know? All right. Guess I will put the CPU back in the Atari 400 so I can set that to the side. Here we go. So Retrotech Die got me some of these silicon mats, and I'm putting them to good use to put under this motherboard so I can plug it in and see if what removing this one 555 timer did to the voltages that didn't look right on that on those capacitors, because maybe the 555 timer was actually part of the problem. Yeah, this isn't going to be a 48-hour stream. Okay. So I can't see what the video is doing, but I suspect I don't have a video image because I've already removed that chip once and it still had a garbage video screen. Still have 3.8 volts at the CPU, but now at the capacitor in question, I've got 4.3 volts and 4.3 volts. Yeah, which is better because it was actually much worse than that. So maybe that's a bad 555 timer chip. But there's still voltage drop, so that wasn't the only problem. So all right, I guess let me see what else is. All right, I guess I'm gonna let this run for a minute or two to see if I feel any chips heating up, or maybe, I don't know, capacitors, transistors. I didn't check those. I guess I'll check some of these other. All right, so that's got 5 volts on it now. That's 5 volts. All right, let's try. That's 5 volts. I'm just going to try some of these glass capacitors at random. Maybe not so randomly after all. It's actually now I know where one of the 5 volt planes on the board is. This makes it easy. Okay, so these all have 5 volts on them down through here. Let me check this row. Oh. There's 5 volts there. I'm just going to check the first one in each row. Oh, wait. Ooh, actually. Okay, I found, I just set my arm down on a chip that felt warmer than I thought it should be. Okay. Well, if I hadn't spilled my isopropyl alcohol, I could use that to find it. Yeah, one of these chips down here. Oh, is that it? There we go. Okay. I got a suspect chip. It is a chip I can't read, but it feels warmer than the ones around it, which may not mean anything, but it's not hot, but it's warmer than the ones around it, which could be normal, and I could be pulling this chip for absolutely no reason. I'm having trouble reading what it is. It says 24S10 on the board. I'm hoping maybe when I remove it, I can read the. So it is a 24S10N TBP 24S10N. It's a Texas Instruments chip. I have no idea what it does, but it did feel warmer than the ones around it. Let me see. That is probably not in the Mini Pro. No. Okay. Let me see if I can even find. Well, okay. First, because I don't know even what it is to know where in the schematic it might be. So we still have 3.8 volts there. Well, we have 4.3 volts. 4.3 volts down at those capacitors. We still only have like, there's still a voltage drop. I have a feeling that chip had something to do with the video circuit. Now that I look at, yeah, I have no video output. So that is one of the chips for the video circuit, which I am actually surprisingly on that page of the schematic. So that is a PROM. Oh, that's a PROM. Programmable ROM. Is what the, yeah, that could be bad. Well, but then again though, if it's a PROM, okay, all right. Given the fact that there was some video output with it plugged in, and the fact it's a programmable ROM, I'm going to say it's probably going to run a little warmer anyways, just by the nature of what it is. Because the ROM chips kind of run warmer than other things around them. All right. All right, I guess let me let this run a few minutes again, and I mean, short of pulling every IC off this board and then putting them back one by one. All right, so I don't think it's the video circuit. Let me try. Yeah, it's 11:30. All right, let me try one more train of thought. Otherwise, I'm gonna have to call it quits for the night. All right, let me go, since I did short the keyboard out, let me go to where the keyboard connector is, and I'm going to just check the ICs that are connected to that. So there's a 74LS74. It is at ZB6. ZB6, that's down. Wait a minute. That's not at ZB6. Resistor might be at ZB6. Hold on, the schematic seems to have a slight little mistake in it, because it's giving me a component location that is not correct. So hold on one moment. I'll try to find the LS74. which actually, I think it is actually at D1. All right. It looks like it's connected to the keyboard connector. So I'm going to pull it out. And let's see, the LS20 that's beside it, does that look like it's connected to the keyboard connector too? Hard to tell. Okay. I'm just going to go on a slight IC pulling spree here. I'm going to pull the ICs that are like immediately around the keyboard connector. So there's an LS74, an LS20, an LS257, and an LS174. And I can't, just kind of looking at the traces of the board, it kind of looks like they might be I don't know. I'm just pulling chips at this point because the real offender is eluding me. All right. All right, looking at the video output, it is quite possible that one of those chips might have something to do with the video and not the keyboard. Well, okay, I still have 4.2 volts down, 4.3 volts down at these capacitors. I see pulling spree. I could use an IC right now, even though they're loaded with sugar. So let me see here. Pin 1 on the keyboard should be 5 volts. And pin 16 at the keyboard should be 5 volts. And I actually do have 5 volts there. I didn't check that before. Okay, that's good. And those IC chips are probably not the problem, but let me see if any of those are in the Mini Pro. And I will test them. Let's see, I believe the 174 is. Oh, I will test the 174. I think these are all going to test fine because, yep. All right, so that's the 174. Actually, there's a 174 right beside it. I think I'm going to pull it and test it since I can. I may also just need to leave this on for a little while longer and maybe one of the chips will really heat up. Yep, that's normal. Okay. Let me see here. They're LS257. Let me see if that's in the Mini Pro. Yes, it is. All right. It's fine. Oh, there is an LS257 a couple chips over, so maybe I'll test it. Thinking just on the thought that shorting the keyboard and these chips are all on the same row as the keyboard connector. Maybe I did something to one of them. I'm sure when I figure out exactly which chip is doing this, I will say, aha. All right, it's not that one. All right, LS20. That was another chip I pulled that was beside the keyboard connector. Is it in here? Yes, it is. All right, LS20. It is in the Mini Pro. And it tested normal. All right, so it's not that one. I mean, granted, I realize that it is quite possible that, well, actually, I'm figuring if they test normal, then it's probably not the chip that's shorted. And then the LS74. And, yep, it tested normal. All right. All right, that did not solve the problem. Let me turn it back on and see if the video is back to the way it was. Yeah, all right. I'm just going to let it stay on for a moment, see if any of these chips get warm. I'll give one more go at trying to find the offending chip. Unless I see any category of chip that is suspicious. Well, let's see. There's a 556 timer. I think that's a timer. I guess I could pull the... Wait a minute. I thought I already did pull the floppy disk controller. The 7404. All right, with those chips in, let's see. Let me just double check. Keyboard connector. I still have 5 volts at the keyboard connector. All right. Oh. Wrong side of the path. I'm just going to check voltage rails. That's 5 volts. I'm just looking to see if any of these are 5 volts. Okay, actually, oh, maybe that's the chip that was warmer. Okay. All right, I've got another candidate chip here. Five volts. 5 volts. Oh, that's negative 1 volt. Hey, 1-bit fever dreams. What is cooking? It would be the one of these chips here. Is that the LS399 or the 174? Or did I get fooled by that? Maybe my arm was actually on that prom chip. Okay, let me just check the voltage rails around here real quick. Yeah, nope, that's not it. Yes, it's actually, I'm using OBS to show the window of a program that is reading the serial output from the multimeter. I can tell you that wizardry is not possible with the Kaiweets multimeter. Even if they do have other features at a budget-friendly price, as Bruce says, that serial output is not one of those features. It's actually a fluke multimeter. Oh wait, that's a diode. That's from 5 volts. 5 volts. It really does seem as if 5 volts. Could that voltage drop all the way down on that? Okay. Oh, I now have 4 volts at the... Yeah, that... Okay. So, I'm still stumped. It seems like the voltage drop is down by the 555 timers, but the 555 timers are not, seemingly not on the data bus. They're indirectly connected. So I still think that is not the... Seemingly, I'm going to find another capacitor that has a voltage drop near it. Like maybe the capacitor, that was a good idea, but that's not it, because that's 5 volts there. 5 volts there. No, maybe that chip's not. No, it seems like the problem is somewhere. I don't know, I'm stumped. This would be the point where I would love for Joe to say, I see your problem. You connected the 2 pins of the processor up wrong, but I've counted 1, 2, 3, 4, 5, 6, 7. That is pin 8 to 40, 39, 38, 30, 40, 39, 38, 37, 36. It's hard to count off the screen because I can't see the pins. Yeah, that is 8 to 36. You know, I'm going to be totally embarrassed if this does it. But wait, I put the other processor in and it still did it, but okay, come on, processor. I know you want to I know you want to come out of the socket. There you go. All right. I'm going to feel really silly. I don't think this is going to fix it, but I'm going to bend. I'm going to bend pin 36 up so that it doesn't make contact in the socket. It will still be held high like it needs to be, but it won't be making contact with the socket. In the off chance that, but I don't think this is going to fix it because the other processor which was working, also appeared to be dead after when I swapped it out. I don't expect this is going to do anything, but yeah, 3.99 volts. 3.9, yeah. Okay, I just wanted to double check that because the schematic shows that that pin was not connected. I just wanted to make sure it really wasn't connected. I guess the other thing I could do, but I will need to check the according to Joe's instructions, pin 36 only needs to be lifted if the oh, hold on. I'm possibly losing screws here. Oh, pin 36 only needed to be lifted if there was a connection to that pin, which I don't think they're actually 40, 39, 38, 37, 30. Yeah, it looks like that pin is actually a no connect, just like the schematic shows. So it should have been fine not having it lifted, but I guess lifting it makes double sure that that there wasn't anything using it. Okay, so here's the one thing I'm going to do. So, although I am going to need to, well, actually, no, this should be fine in either case. So, the only other 68K computer I have at the moment is the Atari 400. It should also theoretically work with that processor. I guess I would at least like to know that that processor is fine, because because it's possible, although that would probably mean I killed 2 chips. Okay, so that is the 6802B chip that was originally in the Atari, and this is the totally legit looking 65 CO2. I just really would like to know that it works. Even though this is Apple II July, well, I guess the Atari is going to have to be my proxy stand-in because I don't have another 6802 system to test this in. All right. It's also not the most stable test rig in the world, and I probably should zoom out in case something spectacular happens. The other problem is that I don't have a composite mod on this yet. I will not be composite modding it tonight just to test the processor, but I do have the TV under the workbench that I am now plugging the RF signal into. I think the TV is probably unplugged, but that should be an easy fix because I think the cord is just right there. Let's see here, turn it on. I guess if there were any doubts that I had a TV. All right, plug the Atari in. Oh. Oh. Oh, there we go. Yeah, the cartridge switch wasn't pressed in. All right. You can't see it, but yes, oh. Until the switch flipped up, I actually do have whatever that cartridge is. Space Invaders. I have Space Invaders on the TV. So that processor would appear to be processing. So if I unplug Space Invaders, and there we go, I got Memo Pad. Yeah, all right, the processor works. Even if I did just break something on the toggle switch. 'Tis but just a flesh wound, I guess. Oh, I guess the metal was slightly bent. Okay. All right, so the processor works. Yay. The Franklin Ace 1000 is not working. Not yay. All right, well, you know, maybe the Atari is just going to be the recipient of that nice, shiny, new processor because, well, I hate to have modded a processor and not put it to use. I'm not sure which will have more incompatibility problems, this processor in the Atari or it in an Apple II, because there are some, I mean, maybe it'd be better to put it in the Atari because at least right offhand, I'm aware of no Atari programs that take advantage of undocumented opcodes. Whereas I think that might be more prevalent in Apple software, but I could be wrong. Maybe Atari software does it more so in various circumstances, but well, we'll see. At least I know the processor mod works. So I'll put the Atari back down in its mediocre storage spot. Yeah, I think the rows of resistors are, I don't know why they did it that way. Because of where the joystick ports are on that Atari 400, I think those resistors are in line with the joystick ports. Yeah, I think it is a design philosophy that got fixed in later years. Or maybe they would have used resistor packs and not resistors, because I think the cost of those have come down. All right, so I started the evening wanting to finish up the Franklin Ace 1000 so that I could button it up and get it off the workbench for the repair that I probably still will start on Thursday. And I now have the growing mystery of I've got something that has gone bad on the board. So I guess the one last thing I'm going to do here, I am going to put this, even though I thought I tried it, I'm going to try it one last time just to make sure. And if this does work, I am going to go rewatch part of my live stream to confirm that I did actually try this and it didn't work. But I have the CPU from the Atari, which was working in here before. I've got it back in the Franklin Ace. I'll actually go to the capture input. I'm just going to try this one last time because I just want to double check that I didn't find a computer that somehow is, I mean, I know I tried this. This was one of the first things I tried after the modded processor didn't work. I think I put this one back in. All right. But I guess the definition of insanity is trying the same thing and expecting different results. But anyways, I'm just going to double check. 1, 2, 3, 4, 5, 6, 7, 8. And I know you can't see it, and that is definitely not 1. Okay. 2, 3, 4, 5, 6, 7, 8. And that is. Please tell me I put the wrong 6502 in there. Wow. Okay, that's weird. All right, so that's the CPU that was in the Atari, which maybe I should have confirmed was still working. But with it in the Ace 1000, I was reading 0.4 volts at the processor. Actually, I'm going to check voltages without the processor in the socket. Oh, it would probably help if you could see what I was doing. Okay, because this is... All right, so that's pin 21. That is ground. Actually, I could check pin 1 because pin 1 is ground. 2, 3, 4, 5, 6, 7, 8. So I have 3.2 volts without the processor in. Let me double check because I had been using this one. 3.2 volts. Okay, that is definitely not right. I am still seeing a voltage drop without the processor, so I guess the probably seeing 0.4 volts with this processor in is probably not a necessarily a sign of fault. But I guess I guess the next step, and who knows, maybe I might, I don't know, maybe I might stream tomorrow just because I'd like to get this off the workbench so I can get to the next project. Maybe I'll pick this back up tomorrow night, even though I don't normally stream on Tuesday nights. But it seems like there is still a mystery. 3.2 volts without the CPU in. I guess probably with a fresh mind tomorrow night, because I think now I've probably got it in everyone's mind that, hey, Justin's going to stream this Franklin Ace 1000 because he wants to get it off the workbench to get to Jeremy's project. Because yes, Jeremy did send me a project, and I would like to get to it. Jeremy would probably like me to get to it. But I think what I need to do is take another look at all of the chips that are directly connected to the CPU and just work my way out on the schematics. And unfortunately, that is going to mean that I will have to start with these bus transceivers again, even though I've already checked them. Well, maybe I don't have to start with them, but I do need to actually, I guess, because I do see, actually, I'm looking at the schematics, and there are two transceivers that I missed before. So, I think they're transceivers or buffers or something, but I just realized. All right, last check of the evening, because I do need to call the stream to a close. If this isn't it, then I'm probably going to put that 555 timer I removed back on the board because I don't know that it really was the cause. I do know with that diode clip, the speaker probably won't work, but I'm pretty sure that that's probably all it's affecting. I don't think the 555 timer is the source of the voltage drop. I guess I will go ahead and put it. Well, no, I'm gonna leave it out. I just remembered. There's those two capacitors that there is a voltage drop at. So I'm gonna leave the 555 timer out because of those capacitors. Okay, so 2, 3, 4, 5, 6, 7, 8. Oh, that's weird. Did I get the wrong pin? No? No? One, 2, 3, 4, 5, 6, 7, 8. Ah, problem solved. 100% voltage drop now. Yay. T8T28. The ZJ11. Okay, one of those two chips. One of those two chips is not the. Well, I haven't figured out what it's a buffer or transceiver to yet, but it's not on the processor. ZJ. No, it is. But I have no voltage on the processor with those chips pulled. Okay, hold on. I'm looking. So 8 volts. Wait a minute. Wait a minute. Did I lose 5 volts completely? $12 volts. 12 volts. That's right. 5 volt. No, I still have 5 volts coming from the because I'm looking at the schematic. The removal of that chip should not have caused 5 volts to disappear from the processor socket, and yet it seemingly has. So, assuming I'm not shorted on anything, and I don't appear to be, pin 8 of the processor should be directly connected to 5 volts. And is not. So apparently one of these two chips is more important than the schematic seems to indicate. Or whatever was causing the voltage drop just ultimately finally failed and is now shorting the entire 5 volts to ground, which I would think would mean I have a chip that is blazing hot. So I guess I will give one last check before I call the stream to a close. And that's only because if I do figure out that it's a chip that's gone bad, obviously if I figure it out now, I can order the chip a replacement tomorrow. If I don't figure it out now, I can't order a replacement tomorrow very easily. All right, let me see if I have 5 volts at the processor now. It does not look like either of those two chips should have been conveying 5 volts, but all right, so I got 3.2 volts. So apparently oddly enough, without those two chips, I get 0 volts at the processor. Those appear to be some sort of a bidirectional buffer. All right, I'm going to take a quick peek at the circuit board on the bottom of the board and confirm that pin 8, because I think that's where the 1, 2, 3, 4, 5, 6, 7, 8. No, pin 8 is not connected from the bottom side of the board. Okay, that must be the plus 5 volt rail, and well, hold on. That is really weird. Why can't I see the, I don't know. It might just come down to replacing that socket, because I might need to remove that socket to see exactly what's going on under it. But anyways, I think the 5 volt rail should be this right here, I believe is the 5 volt rail. And I thought I would see a trace going to that pin right there. And unfortunately, there's a shadow. Yeah, actually, I think I see the. So pulling those two chips should have not affected 5 volts the way I thought they would, because I don't see. Well, I don't see how those chips control 5 volts. They look like bidirectional buffers. Whatever. Okay. Yeah, I think with that, it is time to draw the stream to a close because I am stumped. So I guess I am going to draw the stream to a close, and I'll get a good night's sleep tonight, and maybe I will have an idea tomorrow of some non-painful way to debug this, and I probably won't, and I will just end up probably pulling ICs one by one and seeing if they make a difference. Or who knows, I might get crazy and pull entire rows of chips at once. Because I think the first thing I need to do is find the chip or component that is causing a voltage drop at the CPU socket, although seemingly I have a voltage drop elsewhere on the board. Because I think to figure out what's going on, I need to find the cause of the voltage drop, because there should be 5 volts at the CPU. Because I'm pretty sure I see the trace. In fact, now I'm just even going to pull the iPhone flashlight out, and I mean, if I have to, I will remove the socket to confirm that the chip is directly connected to 5 volts. Which, if it is, then I can see the 5 volt trace that's going to the processor, and it gives me a pretty good idea of where the fault is probably. And it could possibly be one of those ceramic capacitors that's actually on the row of the processor. Or maybe it's one of the no, I'm reading 5 volts at the electrolytic axial, so it's probably not that. It could be one of those ceramic caps around the processor that's pulling down the rail. So anyways, yeah, I'm going to have to put my thinking cap on and probably order some capacitors, because I suspect I'm probably going to have to remove some of these glass capacitors and measure them, because I suspect one of them is pulling the. Probably one of them is bad. But I guess I might have to pull IC chips too, because that could also be it. I guess, though, just to keep these chips safe, I'm going to go ahead and I'll go and pop the processor back in the board, just so I don't get the bad one, or the one I think is defective, mixed up. All right. Well, that is tonight's stream. It certainly didn't end the way I'd hoped. I was hoping I would be able to put the Franklin back together, but it seems like the Franklin wants me to take it further apart. So with that, or I guess as they say on Top Gear, and with that disappointment, it's time to end the show. So now that I have probably ticked off BBC, how about smash that like button? Because I'm sure the BBC won't. If you're not already subscribed, well, what are you waiting for? You'll probably want to know when I go live later this week, probably tomorrow, because I do have a project I'd like to get to later in the week. So I'll try to schedule something tomorrow over lunch. Well, no, the stream won't be tomorrow over lunch. I will try to schedule the stream at lunch tomorrow, because I'm not going to do it now. But I probably will go ahead and continue on this tomorrow, hopefully tonight, or getting a good night's sleep and thinking about that. I will have a clearer mind about what to do, and at the very least, I might order some axial ceramic capacitors to replace these glass capacitors. And I will also find my 1 in 4148 diodes that I know I have somewhere, so I can at least put that diode back. So yes, on that bombshell, it is time for me to click this button. So I hope to see you next time. Take care. Computerized Start is brought to you by my awesome patrons on Patreon and by your tips and memberships on Ko-fi. These and other channel supporters make my live streams possible. You too can become a channel supporter with tiers starting at just $1. Don't forget to smash that like button. And if you've liked what you've seen, subscribe and turn on notifications so that you don't miss the next video or live stream. And as always, thank you for all your support. I hope to see you next time. And until then, take care.